Ammonia-based cleaners are effective at removing dirt, grime, and stains from various surfaces, including floors, countertops, and bathrooms. Ammonia is also a potent disinfectant that can kill bacteria and viruses, making it useful in healthcare facilities and food processing plants. In water treatment applications, ammonia is used as a source of nitrogen in wastewater treatment plants, reducing the need for synthetic fertilizers. Ammonia compounds also have various medical applications, including the treatment of acidosis and the production of pharmaceuticals. As a treatment for metabolic acidosis, ammonia is used to neutralize excess acid in the body. Ammonia is also used in the production of various pharmaceuticals, including antibiotics, analgesics, and antihistamines. Despite its many applications, ammonia can be hazardous if not handled properly. Ammonia gas can cause respiratory irritation and can be toxic if inhaled in sufficient quantities. Proper handling and storage procedures are necessary to ensure the safe use of ammonia compounds. In addition to the applications mentioned above, ammonia compounds can also be used as fuel in various applications. Ammonia has a high energy density and can be used as a hydrogen carrier for fuel cells and power generation. Ammonia can also be used as a fuel in internal combustion engines, reducing greenhouse gas emissions and improving fuel efficiency. Ammonia compounds can also be used in the mining industry, particularly in the extraction of metals like copper, nickel, and cobalt. Ammonia is used as a leaching agent to extract metals from ores, reducing the environmental impact of mining operations and improving resource efficiency. Another application of ammonia compounds is in the production of food and beverages. Ammonia is used as a leavening agent in the production of baked goods, such as bread and cakes. Ammonia is also used in the production of various food additives, such as caramel coloring and artificial flavors. Ammonia compounds are also used in the production of textiles and fibers. Ammonia is used to process natural fibers like wool and silk, improving their texture and durability. Ammonia is also used in the production of synthetic fibers like rayon and nylon, which are used in various applications, including clothing, upholstery, and automotive parts. Finally, ammonia compounds have potential applications in the field of energy storage. Ammonia can be converted into hydrogen through a process called decomposition, and the resulting hydrogen can be used as a fuel or energy storage medium. This has the potential to revolutionize renewable energy storage and make it more feasible to use renewable energy sources on a large scale. In addition to the applications discussed above, ammonia compounds also have potential applications in the field of energy production. Ammonia can be used as a fuel for power generation in gas turbines, which can produce electricity with reduced greenhouse gas emissions. Ammonia can also be used as a fuel in fuel cells, which convert chemical energy into electrical energy with high efficiency. Ammonia compounds can also be used in the production of adhesives and sealants. Ammonia-based adhesives are widely used in wood processing and furniture manufacturing. Ammonia is also used as a sealant in various applications, including automotive and building construction. Another potential application of ammonia compounds is in the production of renewable hydrogen. Ammonia can be used as a feedstock for the production of hydrogen through a process called steam methane reforming.